Number 12, sketching the curve x times the square root of 5 minus x. All right, so first we want to find the domain. We've got a square root function, so the inside of the square root has to be greater than or equal to 0, which means that x is going to have to be less than or equal to 5. All right, let's go ahead and find intercepts. So to find the y-intercept, we plug in 0. If you plug in 0, 0 times anything is 0. So we go through the origin. And then to find x-intercepts, we set the whole thing equal to 0 and solve. So obviously one of the equations, or one of the solutions is 0, which again gives us the same intercept, 0, 0. And then the other intercept is going to be when 5 minus x equals 0, which is at 5. So we also have an x-intercept at 5, 0. As far as asymptotes go, we're getting vertical asymptotes from rational functions when the denominator is 0, or from logarithms, neither of which this is. So there are no vertical asymptotes. As far as horizontal asymptotes, limits at infinity, limit as x goes to positive infinity doesn't make any sense because the x values can only be less than 5. So the only limit that would make sense is as x goes to negative infinity. Okay, well, if x is going to negative infinity, then obviously x here, this is negative infinity. And then if x is a really, really, really big negative number, 5 minus a really huge number is 5 plus a huge number. So 5 minus x is going to infinity, and the square root of a huge number is a huge number. A huge negative number times a huge positive number is a huge negative number. So as x goes to infinity, negative infinity, the function is also going to negative infinity, which means conclusion about horizontal asymptotes, we don't have any. Okay, we are also going to need to know where we're increasing, decreasing, concave up, and concave down. So we need the first derivative. This is x times 5 minus x to the 1/2, rewriting that as a power. We've got two x's here held together with multiplication. You cannot distribute the x inside the parentheses because there's an exponent there. So we're going to use the power rule or product rule. So we've got first times derivative of the second. New power is negative 1/2. And then chain rule says multiply by the derivative of the inside, which is negative 1, plus second times derivative of the first, but the derivative of x is just 1. Let's see. Let's factor out a 1/2 and a 5x to the negative 1/2. So factoring out 1/2 and 5 minus x to the negative 1/2. What that's going to leave us with, if these get factored out, we're just going to have x times negative 1. So we'll have a negative x left over. And then factoring out, remember, means you're dividing by it. So dividing by a 1/2 is the same as multiplying by 2. And as we saw in class yesterday, when we divide 5x to the 1/2 divided by 5x to the negative 1/2, might be a little bit hard to see on the screen, the negative 1/2 power would bring it up to the numerator, and you'd have a square root times a square root, which would get rid of the square root, so you're just left with 5 minus x. So rewriting this then, 1/2 puts a 2 in the denominator, and we've also got the square root of 5 minus x down there. And then left over up top, we've got negative x plus 10 minus 2x. So we've got 10 minus 3x left over in the numerator. Critical numbers occur where the derivative is 0. So that's where the top is 0 and where the derivative doesn't exist, which is when the bottom is 0. So we've got a critical number at 10/3 and a critical number at 5. This is where the derivative is equal to 0, and 5 is where the derivative doesn't exist. Okay, so So then let's come over here and make a sign chart. Let's see, where am I going to fit this? I'm going to come back to this paper, but we'll do the sign chart here. All right, less than or equal to 5. So sign chart stops at 5, and then 10/3 is our critical number. This heads to negative infinity. Let's see, easiest number to plug in here is 0. Going back to the derivative, square roots always evaluate to something positive, so we don't need to bother plugging it in the denominator. 10 minus 0 is positive, so we're positive there. And then 10/3 is like 3 1/3, so we could plug in 4. 10 minus 3 times 4 is 10 minus 12, which is negative. So there is f prime. Okay, we are definitely out of space on this piece of paper to find the second derivative. So we're going to come back here so I can do the sign chart for the second derivative and then sketch the graph. But I'm going to go to a new piece of paper to find the second derivative. And it might take it a second. Make sure it's focused. Hey, focus. Yeah, all right, there we go. Okay. So second derivative, well, let's see, I'll rewrite. The first derivative was 10 minus 3x divided by 2 times 5 minus x to the 1/2. All right, so second derivative is going to be nice and messy. We're going to use the quotient rule here. So we'll get low d high, derivative of the numerator is just -3, minus high d low. All right, so d low, the 1/2 would pull down. There's already a 2 sitting there. So 2 times 1/2 would just be 1. So we'll just be left with 5 minus x. New power is -1/2. And then times the derivative of the inside, which is -1. And then that's all over low squared. Well, let's see. When we square the denominator, that's held by multiplication. So we can just square each piece individually. 2 squared is 4. And when we square square root, you just get 5 minus x. All right, so let's see here. Simplifying in the numerator, let's go ahead and factor out, let's factor out a negative. Let's factor out a negative. And then let's also factor out 5x to the -1/2. So factoring out a negative 5 minus x to the -1/2. What is that going to leave us on the inside? On the inside here, we get a 3 times a 2, which is 6. And again, when you divide 5 minus x to the 1/2 divided by 5 minus x to the -1/2, that's like multiplying square roots times each other. So you're just going to end up with 5 minus x. And then minus, we factored out this guy, we factored out the -1, so all we're left with there, let's go ahead and distribute the minus sign, is a -10 plus a 3x over 4 times 5 minus x. All right, so on the inside here, let's go ahead and distribute the 6. We get 30 minus 6x minus 10 plus 3x. So simplifying the second derivative, let's see, this negative exponent would take it down to the denominator. So all we're going to have left up top is negative, and then on the inside of the parentheses, what's that going to give us? 30 minus 10 is 20, and then -6 plus 3x is a minus 3x. And then in the denominator, we have the 4 that's already sitting there. We've got 5x to the power of 1, and we're bringing down another power of 1/2. So you add the powers, and you get 5 minus x to the 3/2. To figure out what goes on the sign chart, set the top equal to 0, set the bottom equal to 0. Numerator, add 3x over to the other side, and then divide by 3, and you get 20/3. 20/3 is almost 7 though. It's like 6 and 2/3. And remember, our domain was everything less than 5. So 20/3 is actually not in the domain of the function. And then the denominator is only equal to 0 at 5, which is an endpoint of our domain anyways. So for the second derivative, the only number we're going to have on the sign chart is 5. This means that there aren't going to be any inflection points for the graph. Okay, so I'll hold this up here for like a couple more seconds. Actually, you know, that's silly. If you need it, I'm about to move it, so if you need it, pause it at this point to take down any algebra stuff that you need. And then we're going to go back to that other sheet of paper. All right. So let me make sure we're focused here. Looks all right. Okay, so now let's do a sign chart for the second derivative. 5 is the only thing that goes on there, which means the second derivative is going to have the same sign over the entire domain. So easiest number to plug in is 0. If we go back and plug 0 in to that second derivative, we're going to get a negative 20 divided by a 4 times a positive root. So a negative divided by a positive, which is negative. All right, so then the sketch of our graph. Stops at 5 because the domain, we're only going to have a graph for numbers less than or equal to 5. We know we go through the origin. We know we have another x-intercept at 5, 0. And then let's see, 10/3 is about 2, 3, 4 is about 3 1/3, so somewhere in this vicinity here. And we know we're headed to negative infinity as x goes to negative infinity. Okay, so what happens is the graph starts off increasing and concave down, and it does so up until 10/3. So increasing and concave down up until about 3 1/3, sorry. And then it changes to decreasing, but it is still concave down. So there's a sketch of our graph, no inflection points, and the only local extrema is a local max located at 10 2/3.